Okay, we're live. Welcome to the 13th edition of the AI Across the Product Lifecycle podcast. This is Michael Finicaro, and I'm joined by David Priev of Limitless CNC and by Fil Aronshtein of Dirac. Do you guys want to introduce yourselves?
Sure.
Yeah. Go ahead, David.
So pleasure being here, Michael. Thanks for the invite. I'm David. I'm the CEO and co-founder of Limitless CNC. We are an AI startup based in Israel, Tel Aviv, and we're developing AI technology for CAM programming for CNC applications.
Awesome. How about you, Phil?
I'm Phil. I'm the co-founder and CEO of Dirac. We've built what we call the first and only automated work instruction platform. Originally an electrical engineer and roboticist by background. Started the company when I, got my start over at Northrop Grumman, or started the company after I kind of saw how unfortunately archaic a lot of the infrastructure was on the manufacturing side of things, and just wanted to do something about it. So that's us.
Wicked. So our talk tends to be about about AI and how it's changing the role of mechanical engineers, and I think all of us here are mechanical engineers, if I'm not mistaken. If we look back at 2-3 years, we went from AI as machine learning and some Lisp stuff from decades before to, oh my God, it's part of my daily life and I can't live without it anymore. However, there's a lot of skepticism on how applicable is it in the engineering world? Is it just hallucinations? How do you put guardrails on it? So I'm just wondering, like, if you look back to 2022, 2023, Phil, were you really bearish on the potential of AI to transform manufacturing and engineering, or were you a bit skeptical, or you're sort of wait and see?
So generally speaking, I think non-deterministic solutions are never going to be 100% replacing people. I think generally, and I felt this way in 2022. I feel this way still. I think AI tools are going to be force multipliers for folks. I think they're going to generally be 80-20 tools, where you'll have an AI system do 80% of the grunt work for you, and then you'll have a human in the loop, doing the final little bits and pieces of it. Because in manufacturing, a lot of the thing is about a lot of these models, they are trained on the internet. They're trained on data sources that are out there, and
on Reddit,
a lot of
basically, right?
Yeah, exactly.
On Reddit.
The thing is, it's in manufacturing, a lot of what you need to do a excellent job is tribal knowledge. It's context that doesn't exist in a model, and so that's how we built our product. That's how we think about our product. It's how folks on our software team use AI. It's very, very 80-20. I think it's going to be that way for a long time.
Thanks, Phil. How about you, David?
So I have to say that I believe that we're just in the beginning of seeing what we can do with AI and the engineering world, and specifically with the 3D world, CAD, physics. Everyone now thinks that LLM drives everything, right? I had so many discussions with customers, being confident that we're probably running some LLM under the hood, right? Because AI is LLM, right? But the fact is that I believe LLM is just the first wave of AI, bringing the revolution to humanity, and we're going to see tons of new stuff in the next few years, especially on the physical side.
So Philip, you were a little more skeptical, and David, you were a little bit more bullish, I guess we could say, right? So another thing that it's in the news a lot is vibe coding, right? And Lovable has this insane market evaluation and market valuation, sorry. And so, but at the same time, I don't think that anybody is developing software today without using, Cursor or Windsurf or whatever. How are your teams, David, using AI, and is it the scaffolding? Is it for creating PRDs, or is it actually for coding? And is there a difference between the junior programmers or the senior ones? I talked to one startup, and he said, "Oh, I don't give the tools to the junior programmers. I want to learn how to program, but I give it to the senior guys so they can go faster and help them." So I thought that was an interesting way of doing it. So I'm very curious to see, from your perspective, David, and then Philip.
So first of all, I'm a big believer in those code tools. But I think they're just tools, right? Like they're
Yeah.
not going to replace you. And I don't believe that you should do like vibe coding the entire day. Um,
It's bad for
now,
you, right?
now what I see lately, like every month or so, you see like the new model is like performing much better by Gemini, and then it's Claude, and then so what we try to do here at Limitless is first of all allow everyone to have access to all the latest models and just let them try it themselves. It's amazing to see the progress that those companies are making with those tools. And lastly, I would say that I see it very relevant for now, like for classic SaaS applications where you need some front end components, some straightforward back end components. But when it comes to like deep algorithmic challenges, especially with like niche, like understanding how BRAP representation, like how it works, how CAD are running, like it's just scratching the surface when you try to like work with those AI tools. So I think like the core of what we do at Limitless is still very human driven, I would say.
Okay. And yet you're using AI as a way of accelerating and stuff. How about you, Philip? Same thing or totally different?
I would say very similar. I like when I would say everybody on our team uses like AI tools. They use them aggressively. They use Cursor, they use all that stuff. I am very much like a proponent of this. I say here's a company credit card. Spend go rip as many credits as you want. We need to move fast, right? Velocity is our advantage. If you can put money in and get productivity out, like go do it.
Go for it.
I'm very, very much in favor of it. But like as David says, if you're building like a neat little like CRUD app that is just like a database and a cool little UI and it's like typical like B2B SaaS, it's easier to do stuff like that. But when you are working with like really complex like physics simulations like us or any sort of computational geometry infrastructure, it is really, really tough. And like, the LLMs like don't really work super well with stuff like that. And, we're sort of fortunate in that we built, I think, the majority of our like really complex infrastructure, we built it before like all the AI stuff got really good. And I think now that a lot of the LLM stuff and all the like vibe coding stuff has gotten really good, I think a lot of software engineers are like, it's gotten very easy to build like very unsophisticated stuff. And so the amount of like effort and dopamine that a software engineer is like willing to or gets out of like building something, there's almost this like lower attention span for a software engineer on average now because they are so used to being able to get like really easy front endy, like not super complex infrastructure. And so I actually think there's this like interesting moat that companies like Dirac and companies like Limitless CNC end up having because we've built some really, really complex stuff that is not easy to vibe code. It's like nobody is. It's way tougher now for a software engineer to look at something like what we have and say, "Oh yeah, I'm gonna vibe code that," and then the second they like can't, they're like, "Oh, all right, on to the next thing, I guess."
Yeah.
And so yeah, I think the context windows that a lot of these things have also not super great. And so like you very, very quickly, if you're like using Vercel v0 to try to like vibe code something or any of the other vibe coding things, like you very quickly like reach the limits of like the complexity that you can vibe code. And so we use them for we use vibe coding for stuff like writing a PRD or writing features. I would say like the guy who runs product on our team, Jared, is like an exceptional Figma guy and like is a manufacturing engineer by background, so like deeply understands the problem set. Is a software engineer by background as well, and so he can like use AI tools effectively. But like that's kind of my philosophy on like if and when and how to use them. If you do not know, if you can't understand the code that the LLM is writing for you, you should not be using it. And so like I compare it to like for the guys on our team, I compare it to being sort of like a software engineers are now like sorcerers. They're like wizards that can cast like, imps and like, create this imp to go like do my bidding, do like an agent to like go do this like mindless task. If you like, if you're a level 100 wizard and you could just spin up like a million imps to go do a whole bunch of different tasks for you, awesome, great. But like, if you could not have written that code yourself, you were going to enter a whole world of pain when you actually try to like integrate all of these like different vibe coded modules that you tried to build.
Or
So
build a test harness based on it, even worse.
yeah, exactly.
Yeah, I just through a friend of mine discovered anti-gravity, and that's been kind of insane because you can actually create agents for every single coding thing you want to do. It's just it's impressive. But it's cool too to say that the fundamentals of being an engineer, the fundamentals of programming are still critical, because as you said, you have to be able to read the code. If you can't read it, and when it screws up, how the heck are you going to debug it, right? It just I guess the one awesome thing about it is how good it is at documenting itself, though, which is what most programmers are really bad at. What the hell was that loop? And
Yep.
that's awesome. So okay, both of you guys are pretty aggressive in using AI in development. How about like when I talked to to Mauer of Leo AI, another Israeli startup? Mauer actually developed his own LLM, right? Or an LMM, he calls it, large mechanical model. I had him on one of my first podcasts. How are you guys using the LLMs? Are you thinking of building your own model? In your case, David, it would be more on machining and CNC and previous tool paths and so forth, or maybe Phil would be more on the work instructions on how did I build this thing the last time, or last 100 times, or 5 years ago. I mean, are you guys thinking of that, or is it more you're using more RAG to bring in that information? As you're developing the calculation, how are you integrating that LLM power into the way you guys work? Either of you can pick that one up first. I don't mind.
So at the beginning, when we started Limitless, one of my co-founder is our chief scientist. He has a PhD in computer science, and he's an expert like in 3D and AI. And he took a brave decision about LLMs, that it's not going to be part of our core technology.
Okay.
From the main reason that LLM are like great when it comes to text and context. Like, you have like a context, and then you wanted to understand this context and come up with an answer that is relevant for this context window. But when you look on CNC machining, so basically, first of all, the domain is not text; it's geometry and it's physics.
Always, yep.
And more than that, it's not that of a matter like what was the previous steps that brought you to the current material shape, right?
Mm-hmm.
It's all about what's going to be the next move. So it's more similar, I would say, to like playing chess, where every board snapshot is like, it's like a new game, right? And now you need to think, okay, what should be the next move? Having said that, like, we see a lot of value incorporating LLM on the product level, and I'll explain. So I think LLM and in general, all those ChatGPT type of tools are doing great by educating users to interact with software by like writing to it, by communicating with it. And I believe LLMs can be great to replace like bunch of complicated UI workflows and buttons and all those stuff that you usually need to use in the current software, especially for CAD. So let's take, for example, like all the huge toolbars in CAD softwares, right? You have like tons of menu wizards, tons of clicks. Now go figure it out what it's doing. What if you had just one search button where you just text what you want to do, and then it shows you, okay, this is what you want to do, right? And then let's do this. So I believe that LLM has great advantage in simplifying the user experience on the product level. And this is where we will incorporate that for sure.
Interesting. How about you, Phil?
Very, very similar mentality. Like, our core infrastructure, our core like utility is deterministic. It's all physics simulation based. It's a lot of computational geometry, and really it's a lot of mechanically informed heuristics. And so like the core skeleton, the core utility of the product is itself deterministic. Like, we are building at its core really like a new feature, a new product, like building our own category of thing that like today does not exist. Like the first animated, automated, like model-based work instruction that like thinks about integrating the digital thread into the work instruction and vice versa, and aggregating tribal knowledge and pulling that into the digital thread. And so like we thought like, okay, let's lay down that foundation infrastructurally. And then, like in the way that we were building the software, let's keep in mind that we're going to want to have some like probabilistic solutions. We're going to want to layer LLMs in here, all over the place. And so things like classification of components, things like having our own, understanding of what components are and how do they physically interact with one another, having this sort of like mechanical systems themselves, like assembly itself, has a language to it. And so like the way in which we are like over time cataloging and codifying the theory of mechanical engineering lends itself very well to like the architecture of the transformer. Although like, not necessarily us throwing like text generation at like different things. Although very obviously like generating semantically relevant text for like a work instruction is useful, but like frankly not even as useful as people might think. Like a lot of the like genuinely it's like people say like a picture is worth 1,000 words. We like to say an animation is worth 1,000,000. And so if you can actually in this 3D animated environment show an assembly coming together, you don't really need words. Like if you look at the work instructions that like a company like SpaceX has, one of the most advanced manufacturing companies in the world, they don't really have words in the work instructions. It's pictures and icons. It's like their whole thing.
It's like IKEA, right?
Yeah, that's exactly it. You really want work instructions to be like as simple and straightforward to understand and read as humanly possible. There's it should have like a very, very low management index, in that if a manager were to get on the production line and start doing the assembly themselves, they wouldn't actually mess up or hurt themselves. And so you can't just rely on operator tribal knowledge. And so words are often not even like the best thing to describe stuff like that. So a lot of like our core mentality is understanding geometry, understanding physics, understanding how components interact with one another, and being super modular and automated in that way.
That's cool. Yeah, the idea of the instructions being as easy as Lego or IKEA, that's pretty cool. 'Cause, yeah, a lot of the work instructions tend to be kind of hard to understand. So in the actual product in Dirac and in Limitless, how is well, I think you've already almost answered, David, but the user comes in contact with AI. How? I suppose that you were saying that the user gets it from the user interface from the beginning. Is there any AI under the covers? Is there a little bit of work, or maybe it's ML and not really AI, in order to learn from previous experiences and predict what the next toolpath will be? Because you're saying that's the whole thing, is the next step.
So actually, there are two deep technologies that we are incorporating into our engine. The first would be what we call our feature recognition engine. And everyone that are in the CAD domain know what I'm talking about, right? You eventually need to understand what you see.
Chamfers and fillets.
Exactly. The problem is that the current industry standard for feature recognition is mainly focused on CAD features, like, as you mentioned, chamfer, radiuses, slots. But when you talk about machining, machinists are looking absolutely different on geometry. They're like, they put in their mind like what should be the machining operation to apply on those group of surfaces. So basically what we're developing is a neural network that can receive CAD. It's in its native format, and this is important to emphasize, and can label the entire CAD surfaces into the right groups and into the right labels of the machining operation that should be applied on those areas. So we call it like, this is the perception capability of our AI. And we train it on real CAM data. So this is another thing, like how do you train a neural network on this? And second part of the technology is what we call our physical AI engine, which is in a very simple way, it's a decision tree algorithm that try to pick up the best next move to do, the best next step to do out of different options using a sophisticated scoring function that is mainly based on physical estimation of different phenomena in the process, like the chatter or the natural frequencies that the tool can get to based on the geometry of the tool, the deformation of the tool, the deformation of the working piece geometry, based on the cutting force, like all those different physical phenomena that great machinists are simulating in their head with amazing intuition, by the way.
Yeah.
This is exactly what we try to incorporate into the decision-making engine. So I would definitely call the two of them deep technologies. They're much more advanced than just straightforward statistical approach. But it's not LLM as a lot of people want today to see. Like, no, LLMs are like everywhere. So people think that solves everything, but it's far from that.
But you were saying that, do you already have that chat interface on for the front end from the user perspective too?
Yeah. And in general, the way that the user interacts with our product, so it's a co-pilot that is like running alongside a CAM software. So it's not replacing the CAM software.
Oh, so it's like a add-on to Mastercam or Gibbs Cam or whatever?
Exactly. On the back end, it's integrated via API to the CAM session and can execute the recommendation directly to the CAM environment as if a human did that. And on the UI level, so it shows the user what is the next recommendation, and the user can like give feedback, change it, accept it. If we accept the recommendation, we're just generating it straight inside their CAM environment, and then we'll move on to the next suggestion. So this is the current user flow.
So it's sort of one of Philip's imps sitting on his shoulder, looking over his shoulder, saying, "Do that, do that." So what about your imps in Dirac then?
So broadly, the way that we think about like integrating LLMs into like feature sets, kind of like what I was talking about with like semantically relevant text, stuff around how we like the work instruction itself serves as like a really interesting place where an enormous amount of like context and tribal knowledge like finds itself. And the way that we've like built features and functionality in the software today is very structured. And so like we can give you like in the same way that you like might want to like query Google for like context information, we were building effectively like this like context aware production planning platform that you can actually query and like index and say, hey, when was the last time I used Loctite 242 and like what parts did I use it for, and who like when those work instructions were approved, who was actually at my company and who signed off on that, and what happened with that part, like did that Loctite 242 find its way into like the following rev of that work instruction, or like was that replaced with something? So a lot of that context lives inside of the heads of folks who've been on the shop floor for like 20, 30 years. And we are finding that like the work instruction is this really excellent place for us to just aggregate all that context and surface it to folks where they might find it super useful. And even, bringing it earlier into the design phase, that's a lot of how we think about it too.
Interesting. It's also interesting too. You guys are really complementing each other, right? On one hand, David's doing that for the machinist, and you're doing it more for the guy in the assembly line, right? That's interesting. So, how? What about the? Where do you sit today? I mean, Philip, you already talked a little bit about your vision, but now what we saw this year in 2025 was Anthropic's MCP, which was another, a big earthquake in the way that we thought about AI becoming autonomous and having agents, talking to agents and executing entire workflows. What is your feel about that? Where are you going to go with the agentic thing, and what do you think is coming next? That was a bit of I don't know if any of us were really expecting the agentic thing to go that viral so that quickly.
I mean, I expect us fully to have an agent that understands how to use Build OS, and it could just rip work instructions for you. That's kind of the idea. But it's funny, like if we were thinking about mechanical systems and mechanical design like 20, 30 years ago, before CAD was like very, very sophisticated, you would have to have built CAD software first, and then you throw an agent at it to like make CAD models. And we're kind of in like a similar place where there just like is not a robust enough work instruction platform to do as sophisticated stuff as what we're allowing folks to do. And so it's like phase one is you build a really sophisticated platform for the thing, and then you can like throw an agent at it and stuff. And so that'll probably be something we work on in 2026. Not like a super. I mean, people are asking us to do it. Not a very hard thing for us to do and build. It's just, you know, we on the roadmap. One of those things.
Very cool. And you, David?
So we're actually gonna deep dive into the physical integration, I would say, with the actual machine floor. The idea now, like currently we help to program the part, right? But you know, like how the process looks like today, you program a part, you run it to the machine, right? And then usually it never goes well. You take it to the quality inspection, you run the CMM. By the way, you also need to program a CMM program, the program that like has a probe that
Right.
runs on the geometry and gets you like the real dimensions and the offsets from what you need to achieve. So you do that and you look at the reports and you see, okay, wait, I'm missing here. I'm like out of the tolerance. I need to change something on the setup. I need to change something on the program. This is what usually happens. We call it the loop, right? And currently this loop is not automated. It involves zero technology and AI, especially something that helps to take better decisions. And this is where the expertise is needed. So this is what we try to achieve at Limitless, first helping with the programming. Then in the future, we're going to introduce our machine connectivity. So we're going to connect to the machine controller, fetching all the data from the real toolpath, cycle time, all the machine sensors, and all this data will go back to the agent. And more than that, we're going to also incorporate the dimensional reports from the quality inspection, putting that back to the agent as well. Now, imagine you open the projects on the second time and the agent already like figured out for you what should you change in the process in order to improve it. And that's going to save so much time. And it's going to like lower the high bar of expertise required today in order to solve those complex parts. And I'm talking about parts like, you know, in aerospace, defense, medical stuff, like complex geometry, tight tolerances.
There's stuff you were
This
running
loop can
around
take...
Tel Aviv to find in this story I wrote about Limitless. Is there going to be a Limitless CMM then? You're going to do a CMM module too?
This is also part of the
That's what it
process. By
sounded
the
like.
way, it's a very similar technology. It's still like a CNC machine, just runs the probe and not cutting the material.
Very cool. How about you, Phil?
I mean, we're not going to get into CMM ourselves, you know, but a lot of how we think about like what we're going to be building in like the future is us getting into like automated factory layout planning, automated maintenance and repair instructions, you know, automated inspection and quality routings. We're actually getting into DFM right now. A lot of how we actually dub ourselves the assembly company. A lot of people care about how to make parts. We don't. We care about how to put them together. And so that's a lot of what we focus on is just how, you know, how are we doing production planning in a facility? How can you take context from one person in one workflow and bring it into another? Like we think every piece of data, every piece of information in a manufacturing facility is one node in a very deeply interconnected graph. And so when we look at the work instruction, it's sort of like a bundle of these nodes, and we just draw a rectangle around it, and we call that a work instruction. But you know, the industrial engineer doing factory layout planning has this like top-down macro perspective of work instructions and how they interact with each other through space, time, and that is their perspective, which you look through the lens of like factory layout planning and, you know, doing a bunch of different things that they end up having to do. And so that's kind of like how we intend to, you know, build stuff out at the high level.
So it sounds like you could almost, you could even do the service notes in a sense.
Yeah, definitely.
That's really cool. They're a little out of schedule. I thought if I could ask, I mean, you guys are both doing stuff that arguably the big three should already be doing, right? I mean, already Siemens and DS have invested billions in manufacturing and in, you know, and Innovia has work instructions, and they bought a Priev. And I mean, where's the gap? How are you guys able to compete? Because you think the customer like, oh no, but DS, the DS guy sold me the thing, and I mean, it's pretty awesome that you're able to do it. And I'm just wondering what's the secret sauce, because probably other startups will listen to this and be like, well, no, I'm not going to, or maybe someone will listen to the podcast and they'll be like, no, I'm not going to do that because I'm going to be killed by the big guys before I even get my idea out. Because I find you guys super courageous, you know?
It's a really valid question. So for context, we have a really, really great partnership with Siemens. You know, they've brought us into customers, like we're going after customers together. We're really, really tight. Like we have an integration with Team Center. We have a really, really good relationship with these guys. And like, I've often asked myself the same question, right? Like, why have the big guys not built something like this? And then, you know, one could make a whole bunch of different arguments. You know, the canonical classic startup argument that a founder makes is always like, the big guys don't build anything, you know, it's, you know, why won't Google build this? It's like, oh, Google doesn't build it. You know, it's, I find those arguments to be like somewhat compelling maybe, but like, I think it's really just like the technology and the infrastructure that they have built over the past 20, 30, 40 years is pretty sophisticated, but what they are exceptionally good at is not necessarily building, it's selling. Like their power is in their distribution. Their power is in their relationships with their customers. The number one thing they have is customer trust and customer loyalty, because the thing that a massive aerospace manufacturer cares about almost more than technology and capabilities is the company that I'm working with, is this software, is this technology going to be around in 5-10 years? And so, you know, big companies have to work with big companies. It is very, very tough for a startup to earn like the trust of a prime or of a massive automotive manufacturer that they'll be around in 3 to 5 years. You know, I would say that is one of the key things you have to do in building a software, selling to those companies, the big guys, you know, the enterprises, and especially in a way in which you like might be adjacent to or might have to integrate with the, you know, the big three. You know, you're going to have to make a really compelling argument to the big guys that like you're going to be around. And so I think we're very fortunate. We've been able to do that. We've been able to show that we have this, you know, 1,000 times better piece of software that like does not exist for anybody today. It's a real massive pain point for people. And so, you know, we've been, you know, very fortunate that we could solve that problem so aggressively for folks. And also be able to integrate with the existing ecosystem. I think both are very, very key to win.
So it's really stickiness. It's really for you one of the most important things.
I mean,
do you
our
have
whole
this
perspective is like what CAD did for mechanical engineers. We have built this like 21st century upgrade to the workflow for manufacturing engineers, something that like does not exist at all today. And so if you can make that type of argument, then you know you could stand a chance.
David, what's your experience?
So,
of course,
first
you're in
I
a
would
more
say-
fragmented world, though, right? Because the CAM world is relatively fragmented. There's no huge, well, Sandvik, but Sandvik has actually 5 different CAM packages, right? So sorry, it's not exactly the same, but.
So yeah, it is a fragmented market, but when you look at the enterprise landscape, you will still see like the big 3-4
NX
players
Cam,
dominating in NX, 3D Experience, and CATIA, PTC, by the way, as well. Mastercam.
Autodesk, right? I mean, Fusion's got some great manufacturing.
Yeah, although Fusion are more looking into like small, medium market businesses. Anyway, what I was trying, what I want to say is that, like, let's say I will be very unconfident trying to build the next CAD or CAM platform to compete with what exists today, because those tools are like, they went through so much, right? Like they're so solid and it's so hard to like transfer a client from one data type to a new data type. So it's almost mission impossible, right? But if you think about a solution that is like a new layer, right? You don't need to change anything in your stack. And this new layer actually brings a lot of value without changing anything, and it's integrated into your workflow. So there you go. You have like a new opportunity here in the market. This is what we're trying to do with this agentic layer of a copilot that runs on top of CAM. And regarding the competition, so yeah, for sure, they have teams that are working on this, but there's two key things that differentiate, in my opinion, like startups like us and the large players. First, they need to maintain like a legacy solution, right? So how much
Technical
of their
debt.
energy actually goes to like changing core capabilities, like reinventing the wheel there? Not a lot of energy goes there, right? Secondly, I believe that like young startups with a compelling vision and a good funding backing can like recruit amazing talent that usually will not think or consider to go for those large players as an AI career, right?
Yeah,
And this critical talent, especially when it comes to AI, can be a game changer.
absolutely. Um, Actually, I just got a question on the chat from Matt Ferrero, who says, "Do CAM programs usually compute the cutting forces and temperatures on the tool and part? Does Limitless calculate that? And are you able to detect things like force spikes and when cutting inside corners?" Good question, right?
That's a very technical question, and I like it. So first of all, 99% of CAM softwares do not calculate those type of stuff. CAM and CAD, by the way, CAM like brought into the world out of CAD, right? You had CAD at first, and then we say, okay, we can
Actually, you could
do.
argue it goes the other way because was the guy that invented ACES, he actually started on doing a manufacturing software before before ACES became the CAD software. But anyway, you're right. There is a
That's interesting. Like
yeah, big,
if you look
yeah,
at Siemens, Autodesk, Dassault, those guys started from CAD, and then they brought the CAD ADA into CAM. Before that, you had G code, right?
you're right.
So all of those softwares are basically very geometry oriented, kinematics oriented, but
Not
have
so
nothing to
physics
do with
oriented.
physics.
Yeah.
Exactly. When you want to incorporate physics, you either need in like a third party solution like Vericut that can simulate the tool path and calculate the forces and the process, and then it can calculate the parameters that were raised. Or you need to go like deep into like finite elements, start like, building and modeling the process on your own. Like there's no out of the box features in CAM that doing this today. And this is where the value and the opportunity is. Like this is what's happening inside the machinist mind all day long when they program, like they think
Mm.
about those stuff. So we want to bring that into the AI.
And so your answer to that question is yes, Limitless is aiming to do that.
Is taking that into consideration in the physical engine, but we're not like showing the user all those different calculations.
Right. I actually have a friend of mine that's a NX cam guy, and he was telling me about how much physics is in there between the velocity, actually the acceleration and deceleration, how you get rid of the excess material. I mean, it's just, and he just said the math is just more or less insane. How about you, Philip? We've been talking too much
I
about
mean,
cam and not enough about work.
hey, I mean, I love hearing about CAM. It's kind of funny. You would imagine that people who know about CAD would like happen to know a lot about CAM, but like actually not a ton.
Yeah.
I have friends who use Cam daily. I have friends who I literally have a friend named Cam who like it's an incredible company. Gonna plug in for a second. A company called Rangeview. They do casting. Incredible company. And I would say like I hear a lot about CAM tools. I hear a lot about how they're advancing. But we the wor- I generally think that the way in which like software on the manufacturing side and the design side has developed has become almost a little too generalized. Like I like that there is this more like Michael, you know Brad from NTOP, right? Like I'm a
Yeah.
very very big fan of NTOP and of Brad. But like they're very very focused on parts. And
Yeah.
I think generally speaking, like CAD software has become a little bit too generalized in that when you were building out like an assembly or a system, you can design a part and you can also design an assembly at the same time. and it's almost like you're not allowing yourself to pin down enough variables to be constants, and you are building systems in like too flexible of a way. Like it's almost like I'm sort of totally taking this on a tangent here, but a lot of my soapbox is like, in order to manufacture really quickly and effectively, you need to pin down more variables. You like cannot necessarily allow designers and engineers to have as much flexibility and as much creativity as like they might want to and currently have in CAD software, because in CAD you have this sort of like limitless 3D environment, and you can build like this platonic ideal of a system. And by the time it like gets to a manufacturing engineer and their job's to figure out, okay, cool, got this CAD file, how do we actually make this thing? They now have to like rework the design a ton to be designed for manufacturability. And a lot of like how we think about stuff, a lot of how I like hope we start pushing more and more is adding more like manufacturability, like real world constraints, bring that
Right.
like here into the design process, such that like CAD is a little bit more guardrailed around like
Right.
the world, and design is a little bit more guardrailed. So that's
Yeah.
kind of how I mean, the CAM conversation was making me think a little bit about that.
That reminds me when I interviewed Sorab Hagikat of Hestis, and he was talking about how uh, the problem with 3D printing is that the generative design is you get these organic things that are not manufacturable, right? And if you don't have a 3D printer and you really have to do it on a milling machine, you have to redesign the whole thing. So his whole program was, his startup was that now I'll give you the real geometry that's manufacturable. It also reminds me, I was invited, I missed out on the a conference in Austin because I was invited to speak at a conference in Scandinavia in Copenhagen, and this startup asked me to come in, and they created a thing called RD8, and I thought, oh, Radiate, and they said no, Rugged Design 8. I'm like, okay, but Rugged Design apparently is a whole thing that they do in Scandinavia, and it's you look at a design and you remove you add the constraints, you look at the constraints and you find like the thing. It's basically what you were asking for, Phil. He's
Hmm.
it's pretty interesting. I'll
Love it.
put you in touch with him.
That's awesome.
So like so let's talk a little bit more about when you take the thing you take it out of the little paradise garden or the Plato's cave, and you now put Dirac and Limitless in the real world. So two questions. The first question is I look at digital maturity on a spectrum of like 1 to 5. 1 is like I'm still doing email and using Excel, and 5 is like autonomous, agentic, adaptive digital twins. And basically nobody's at 5, right? Barely anybody's at 4. Maybe a handful are at 3 or think they are. You know, so is in your experience, where do your customers sit? And maybe it's an industry thing. Maybe some industries are more advanced than the other. Like, for instance, if I just throw in one into, I talked to a company called XMPro. Peter is very, very active on LinkedIn. You've probably seen Peter's post. He told me about the mining industry. The mining industry came from like the Stone Age in terms of computer stuff. And the last 10 years, they are now one of the most advanced. They have these awesome autonomous vehicles. They're going up and down the mine. They have the most awesome battery technology on the planet because, an incline like this with a carrying ore on it, the battery is like dead within 3 seconds, right? So it's insane. They went from nowhere to like almost to 4 or 5, all 5 big mining companies. So you guys aren't in mining. You guys are doing other stuff. Where do what's your opinion on that?
I've never run into a 5 for sure. I don't think 5s really exist in manufacturing yet.
Yet.
I've still not really a 4 yet either. I haven't really seen any, maybe like 1 4, and I was sort of blown away. I'd say the majority of our customers fall into 1 to 3. I would say it's probably a little bit of a bell curve, like sort of mostly in 2, a handful in 1, a handful in 3. We found that folks sort of like across that spectrum love what we're doing. When people are in 1, maybe there's like substrata of 1, but like one asks like many times, do you even have a CAD file of your assembly?
Right.
I would say depending on like what industry you're in, aerospace and defense and automotive folks like basically always have CAD. We work with folks we're vertical agnostic, right? So we work with folks in aerospace and defense, automotive, ag and construction machinery, maritime. I'd say the ones who are least likely to have a CAD file, and they might just have a 2D drawing, are Midwestern like ag and construction machinery like OEMs who like have it might be like a 50-person facility. There's like a 50-50 shot if they have CAD files. If they have CAD, then they are like fully CAD'd up. Everything is great. If they don't, they're like still working off of like a 2D drawing for their assembly. It's very, very binary. And then in maritime, it's like very, very paper based,
I'll
which is
bet.
unfortunate. But we're trying to help push that a little bit more forward. I would say, for the most part, everybody there seems to be like a unanimous willingness to adopt what we have, especially if they are like everybody's experiencing the workforce problem. Everybody's experiencing loss of tribal knowledge. So it's very obvious that what we're building is needed. And so we end up being able to work with tier 1 to 3 suppliers, OEMs, mid markets, enterprises. It's sort of like if they have parts and they fit together, that is a customer for us. So we get to see a really broad spectrum.
Awesome. How about you, David?
So when it comes to like part manufacturing, it's pretty interesting because like the technology that you have today, CAM softwares, CNC machines, like all the technology around it, cutting tools, there's a lot of functionality there that allows you to basically build your own rule-based automation, right? Like new CNC machines has so many cool features in it, like tons of automation, tons of smart stuff, sensors, everything. CAM has like tons of capabilities that usually you just scrape like 5% of its capabilities. And the interesting part is that I would say if users and machinists and manufacturing folks were like highly educated about those new capabilities in the market, I would say a lot of them will be probably hitting like somewhere in around 3. But unfortunately, because no one teaches you today how to CAM program, or no one teaches you today how to leverage all your CNC controller capabilities, so you basically end up by getting to the plateau of the organizational knowledge. And if you have some experts, that's great. They're going to teach you some stuff. But if no, like you're stuck. And then you see most of them are, I believe, around 1 to 2.
Wow. So then that does give you a huge opportunity, right? Because I was thinking, and my thesis was that a lot of companies that are relatively low to the left of the scale, when they get something awesome like Dirac or Limitless CNC, and they see what you can do when you've got better control of your data and less silos and CAD files, just even something as simple as that. Is there have you ever had that feeling like when you put in your software that there's a sort of an aha moment, like, oh,
Yep.
that's what the digital revolution is. Or is it
100%.
a ripple effect? Or are they like, that's nice, but I need a couple of years to kind of really understand it.
So something cool that we've seen is oftentimes there's 2 big things that we've seen, right? When it comes to actually like what does a company that makes a thing care about? They care about manufacturing, right? They care about actually getting a thing off the line. They care about getting a part out the door or an assembly out the door. And so a work instruction is very tangible to them. And so when they see that, hey, we have this 3D animated automated work instruction platform, and we say, yeah, the only input to this is a CAD file, they're like, oh, that's why we need CAD. Yeah. And so in the cases that I kind of described where there's paper based, what's happened like several times is we have come in the door, they've said, we need this. Management says we need this. And that has actually catalyzed them to CAD up and like adopt CAD and CAD up their assemblies. And so it might take, an extra couple of months before they could start using us, but we are like the catalyst for them to start adopting CAD. Similarly, on the, that's on the left side of the workflow. On the right side, it's, operator consumption of instructions. A lot of these guys, we do have like a PowerPoint or Word doc or, a PDF export that you can print out, but like we also have an operator viewer. It's kind of the whole thing, right? We allow an operator to interact with this 3D animated model. And to do that, you need a screen in some place in the shop floor. You need a monitor or a tablet or something. And I would say maybe like 30% of the folks that we work with initially like have some sort of screen on the shop floor. And so they will often start out printing our instructions out. And then they're like, oh, we've been trying to get tablets on the shop floor. We've been trying to justify getting a monitor at these stations. Now we can. Now there's totally an obvious use case. So like now let's go get a bunch of monitors. Let's set up these stations. And so we've seen like a really, it's like within 2-3 months of adopting the
Wow.
software, they go from being like paper to having monitors and operators with the operator viewer, because they're like, oh, cool, now we can actually justify the investment because it's so obvious. Like, we reduce error rates. It's like a whole thing. So I would say to the left, we are a really cool catalyst for some, a little bit more archaic facilities to both adopt CAD and then also to adopt monitors on their shop floors. Because it's just like we are the connection point that binds the engineering and the manufacturing workflows.
Very cool. How about you, David?
So we had two crazy aha moments that like we really remember. The first was when one of our users, like at one of the company that works with us, like ran our recommendations step by step. And each recommendation, he's like, yeah, that's interesting. Maybe I'll do it differently. And then he accepted. So we got another step and another step. And eventually he finished the program. Like he had like 30 steps in his CAM environment in like 15 minutes. And at that moment he was looking, wait, I'm done. Like I actually programmed the part. And they were super excited about it. And that's what gave them like the motivation to try it again and to continue using it. And the second thing was, actually we had a very interesting use case of a team that onboarded a CNC operator, the one that runs the machine, into the programming team. So he has no experience with CAM, and we introduced him to our product, or we call it CAM agent. So basically the CAM agent started showing him recommendations. He accepts them because he has nothing else to do. And then he opens the recommendation, like he opens the operation that we just created in the CAM, and then he goes through the parameters that we selected. And by that, he starts learns how to like program. Like it actually helped him to figure his way out, his way into the CAM environment and to the CAM programming, because it looks very intimidating when you like see CAM or CAD. Like it's like a airplane cockpit, like too many buttons.
Yeah.
But when someone like give you some steps at a time, it really helps.
Very cool. Very cool. Well, we're almost out of time. I thought that was really, really insightful. Thanks, guys. Any closing comments? What are you guys going to do? Are you guys coming into any conferences? Is there any places we can see you in the next couple of months?
We got some folks on our team over at Workboat right now. Workboat's a really cool maritime conference. If anybody is listening right now who is at Workboat, go see our guys.
Awesome.
That's cool. We're gonna attend 4 conferences probably, like in 2026. It's gonna be Hanover Messe in Germany, and then 2 Siemens events, the Realize events in Amsterdam and in the US as well. And lastly, IMTS.
But nice, very cool. I want to get to prove it. I want to do that one. That one looks like so cool. Anything else? I mean, that was really awesome. I think I learned quite a lot about CAM and about assembly. Actually, I wanted to say that I realized also that I was confusing part and assembly stuff. Like to your point, Philip. Like when I was writing this book on the history of CAD, I realized that I need to separate the history of how we did parts, which is really the PDM problem, from how we did assemblies, which is more the PLM problem, right? It's sort of product structure, and then all that other stuff was sort of that next generation that created PLM, because then you needed change management, configuration management, because you're dealing with multiple parts. And then of course on the machining is like, how do you go from CAD to a real part, right? Which is really cool. That's awesome. Well, I think we're good for today. I want to say thank you very much to both Phil and David for taking time out of your busy day to tell us, give us your opinions and your perspectives on AI. And I want to say thank you to the folks that joined in. And of course, this will be on the YouTube channel. And feel free to reach out on LinkedIn to Phil and David if you've got more questions. I think that David, you've got a couple of questions from that same Matthew Ferraro in the queue. You might want to check those out. He had some good questions. Thank you very much. And we'll see you on the next episode. Tomorrow, December 5th, I've got Null Space, so Masha and Misha who from Infinite Form. So it's going to be more on the simulation CAD side tomorrow instead of manufacturing today. Be really fun. So looking forward to seeing you guys tomorrow. Thank you.
Thank you, Michael.
Thanks for having us. Catch you soon.
So how'd you like that? Was that good?